Okay, so let's go ahead and jump right into it. This question I don't necessarily like because it has nothing to do with stickers, but still the idea works the same. So if we want to, we're going to press this green button to go ahead and run the code, run the packages in order for us to get access to the data. And I'm just going to do something quite strange, not strange, but it's going to allow us to see our data a little bit differently. Let's see, not differently, let us see our data. So when I press view, the birthdays, I want to see if the birthdays regarding people's day that they were born, it was equally likely. Okay, if it is equally likely, and so I want to see if Friday is as equal as Sunday, which is as equal as what's the other days of the week? Wednesday, so on and so forth. Okay, so ideally, if it's equally likely, that means that the likelihood of each of those days is 1/7. So keep that in the back of your mind. So all you got to do is, for us to see this, to get some summary data. This is more so going to be frequencies. We're going to do. Come on, Emmanuel. What's the name of the birthday? Birthday. Okay, weekday. Okay, boom. So this should give me a frequency of all of the days for each day. Okay, so frequency of Friday, Monday, so on and so forth. I could have put it in order, but then that's going to make it too complicated. Just for funds, this is not going to be on the assessment, or you're not going to be questioned on it. Oh, maybe it could be, but this gives us the proportions, okay, for each of the days. Okay, but that's neither here nor there. It's me trying to be fancy, teach you something extra. Okay, so let's then look at the visualization, and the only thing I have to change here is to name this birthday, birth weekday, and then do the same thing for fill. So X and fill, and these colors you can change. These are the only colors that came to my mind when I used ChatGPT. It didn't work. What did I forget to change? What does it say? It says, oh, that's why. Alright, well, since this won't work on your end, so then just see what I did here. I put a hashtag in front of these two things. Okay, now this should work. Okay, this should work. Why does it take so long? So annoying. So here you get the frequencies for each of the days, which is the most frequent, Thursday and Wednesday, which is the least frequent is Sunday. How is someone born on Sunday? Whatever. Okay. Remember, the null hypothesis is that they're all equally likely. That's probably a question on the quiz. That's me being nice. And then the alternative is that at least one of the proportions is not equal to one of the ones that we expect, which is 1/7. And so we can go ahead and look at this. This is my null hypothesis, okay, in terms of expected proportions. And I'm going to test this using the chi-square test, okay, and I'm going to change this to be birth. Is it birth? Not birth month. Birth weekday. It should give me an error because I forgot to run this. And then here is my p-value. And here is my corresponding test statistic. This is why this tells you, right? If we were doing symmetric, if we were utilizing the t distribution or a z distribution, which is unimodal or symmetric, you would want to say, oh, it's a large test statistic. No. You have to look at the corresponding p-value for chi-square test, which will tell you to do what to your null hypothesis? Fail to reject it. Okay? Let's keep going. I want to do 2 videos, but now let's keep going. So here, what we're going to do is look at the association between birth weekday, like we just looked, the variable that we just analyzed, and the purchase location, okay, where people want to purchase their actual Cal Poly gear. So we're going to take this, and I'm going to just play a game of copy and paste. Okay, and then I'm going to just put a comma here, okay, just because of time. We're going to run this. This is going to give me the summary table it's going to be a contingency table of our data, okay? So by looking at this, you should automatically remember one of the assumptions regarding, well, technically this is supposed to be the case here as well, but we have 5, we have exactly 5. It should be more than 5, so therefore this assumption is validated. It's not met here, but it's also especially not met here. So a lot of students typically ask me, when it's not met, what should you do? You keep going with regards to your analysis, but you articulate to yourself and the stakeholders that the assumptions have not been met, and that each of these categories should have at least, it's at least five. So at least five elements within it. Okay, and so there's a problem here. Okay, it's a problem that we're not meeting that assumption. Okay, and so what are we going to then do? Do some back end stuff a little bit. I'm going to copy and paste these two variables. I'm going to put it here for, this is some background analysis or background summarizations that need to be done. Well, let me not cause a fire here. Okay. Yikes. Okay, I'm back. So with that being said, I can now run this. Okay, there should be no errors. Birthday not found. Interesting. Let me pause this and fix this. Okay, so I'm gonna have you do a little bit of some small changes. What you're gonna do is you're gonna put this in double quotes. You're gonna put it in quotes. So put a quote here, put a quote here, and then capitalize the letters. And I'm gonna run it. I haven't ran it yet. I'm assuming this is gonna work. Run it again. So now it works. Okay, good. And so what we're gonna now do is say on the X variable in the next visualization, is going to be birthday weekday, and then for the fill, we're going to say that it's purchase location for the Y, and this should create the plot. Oh, it's gonna be an error. Okay, you can put a hashtag in front of theme custom and then run it. That should work. Okay, that's fine. So now you have the frequencies on top of the bars, and you also have the bars. It's the bar plot, so you get to see it. It's cool. Good job. All right, so which one's the most frequent? Wednesday, and it looks like those that are born on. Everyone likes to buy the bookstore regardless. That's important to note. Regardless of the distribution, it seems as if it looks the same in each one. So therefore, one can argue that they are independent from one another. I already know that's going to be the case because I already did this. But what we're going to now do is take these same variables, birthday and weekday. I'm going to play the game name, copy and paste, because I don't want to make this video too long. Okay. So I'm going to select these two variables from the data frame, and I'm going to implement the chi-square test on them. Okay. And look, my test statistic is large if it were to be a symmetric distribution, symmetric unimodal, but I'm looking at my p-value, 0.56. So we're going to fail to reject the null hypothesis, indicating that that based on our data, we can't reject that they're not independent. Okay. And so look at that. It says chi-square approximation may be incorrect. That's because of the sample size. We're done with small sample sizes regarding these levels. So take note of that. Okay? So hopefully you're able to answer the questions and fill out the... Did it say it here too? It did it. Okay. Fill out the actual test or whatever it is, lab 2. Have a good one. Thank you.